All right, what's up, everybody? So today we want to start to take a quick look at how we can create a confidence interval, specifically a 1 proportion Z interval with our graphing calculator. So let's do it. So when we go to our graphing calculator, right, all the intervals and tests that we're going to use, we're going to press this stat button, go over to tests here, right? And throughout the rest of this course, we're going to learn how to use many different testing intervals listed in this bank. Currently, we're working with, for me, it's letter A. It probably is for you, but maybe it's not, depending on your calculator model. We're currently looking at our 1 proportion Z interval. And so what we want to learn is, how do we pop the correct numbers in here so that we can produce a confidence interval with our graphing calculator? The confidence level is how confident we are. And we'll talk more about how we choose that, how that interval, how that value affects an interval. For now, like that's either going to be given in a question. If not, pick one. When in doubt, pick 95%. And again, we'll learn more about what levels we use and why. But the general rule is if you're not given one, just use 95%. The confidence level does always have to be entered as a decimal. I'm pretty sure we know what n is. So really, we just have to talk about this x value. So, wait, stop share so I don't film the whole video with the wrong screen shared. So we want to look at this. So when we're working with any 1 proportion Z interval context, any situation where we have one sample, or actually this is also true when we have 2 samples, but any situation where we're working with categorical data and proportions, whoops, we're going to need to consider a few values, right? There are the ones we just saw listed on our calculator screen. So we need n. I'm pretty sure we all know that's the sample size. And by pretty sure, I mean you better know what that is. We need our confidence level, which, as I mentioned, is going to be something that's given in the context. If not, then just use 0.95. And although the confidence level is a percentage, we're going to have to write it, I think, as a decimal. I don't know if you put it in 95 if it would work. There's only one way to find out. Try it, see what happens. And so our primary focus is what's up with this x. That's the one new thing. Oh, sorry. We also need to know what p hat is, right? Our sample percentage. That's something we should also be familiar with. And so again, right, the new thing here is this x value. So here's the deal with the x value. A few things we have to know. And this will make a little more sense, I think, when we look at an actual context. So p hat represents the percent of success, right? Success is a generic term in our sample, right? That's our sample percentage. X represents the actual number of successes, again, a generic term, in our sample. I could give you some formulas, right? But don't overthink it. Let's say we have a sample of 100 students, and let's say I know in that sample, 20% of them take AP Stat. I would hope that would be a higher number, but whatever. X is just, that's a real sloppy 20%. So P hat is the percent of the sample that takes AP Stats. In this example, X would represent the number in the sample who take AP Stat. I mean, don't overthink it, right? All we have to do is think about what's 20% of 100. And I'm sure a lot of us realize that's 20, but all we're doing is finding 20% of 100. So we could write X as a formula. X is n times p hat, or p hat times n, right? The order doesn't matter. I know I didn't match them up, right? 0.2 is really p hat and 100 is really n. You know, that's how the formula is traditionally written. So yes, we could have a formula for the x value, n times p hat, but don't overthink it, right? Just find the percent of the sample, right? If 20% of the sample takes stats, that means 20 out of the 100 people took stats. And similarly, if we want to, we could do some algebra to write an equation for p hat, right? I could divide by n on both sides. And so I can figure out that p hat is x divided by n. But again, that would just be finding a percent for a sample, right? This is just based on our simple understanding of percentages. So don't get too caught up in the formulas and overthink it. We need to be able to recognize both of these. We need x for the calculator, but sometimes a question will give us p hat and we have to use it to find x. In other instances, a question will give us x And we'll want to use that, right, to find p hat, but obviously we'll also have the x value directly in that case to pop in the calculator. The one thing you really need to know about the x value, so the x value must be rounded to a whole number. If you put a decimal in for the x value in your calculator, it's going to say error. And you can't call me over and ask me why it says error, right? You have to know that that's the problem, right? So x always gets rounded to a whole number because it represents an actual number of things happening, right? In this made up green example, it represents a number of people who take AP Stat, right? That can't be a decimal. 20.37 people can't take AP Stat. So let's just look at two quick examples. So here's the first one. Got a survey of approximately 4,200 high school students in the Midwest, showed 19.8% were hypertexters. And then we have a definition there just of what hypertexting is. I mean, we're probably all like hypertexters now. This is kind of old. This asks us to estimate the percent of all Midwest high school students who can be categorized as hypertexters, hopefully based on today's first notes on confidence intervals. The only way we could estimate P, the parameter, this would be a full confidence interval question. But for right now, we just want to be able to define these values, N, P hat, and X. Like pause the video and do that. So in this example, we've got N is 4,200. No big deal there. We're also given, in this one, we're not given X, right? So we're given P hat is 19.8% or 0.198. So in this example, we have to calculate X. And sure, right, I could like memorize X equals N times P hat. But right, all that's saying is, all we're trying to figure out is, we know that for the X value, we need the number of students of the 4,200 who were hypertexters. So I don't need a formula, right? I know, I mean, I could use one, right? But I know that 19.8% of the 4,200 were hypertexters. So to find the number of students who are hypertexters, I'm just trying to figure out what's 19.8% of 4,200, which hopefully we all know is 0.198 times 4,200. And if we don't, we can rely on this formula, right? I'm going to write it backwards here, N times P hat, right? But whatever, same thing. So X is just the actual number of successes, in this case, hypertexters in the sample, right? All we're doing is finding 19.8% of 4,200. Now, when I do that, I'm not going to switch sharing screens, but when I do that, 0.198 times 4,200, right, comes out to be 831.6. So our X value is, we cannot use a decimal because this represents like how many of those 4,200 kids were hypertexters. Like you can't have 831.6 hypertexters. So we're going to use an X value of 832. And if you're wondering why this came out to be a decimal, I would assume that this percentage was rounded, right? And that's why when we're working backwards, we're not getting a whole number. If I want to actually create the confidence interval now to see how we use our calculator, I just go to my graphing calculator, I go stat, over to tests. That's where all these intervals and tests are. I'm going to hit alpha A because I know it's letter A. So now 831.6, nope, can't do that. It'll say error. Here, I'll show you just in case you don't believe me. N is 4,200. We weren't given a confidence level, so we'll just use 95% confidence. Like on the AP exam, you're probably given a confidence level. Go to calculate. Oh my God, it says error. This guy wasn't even lying. It really does say error. So if I go stat tests alpha A, the error is the number of successes has to be a whole number. And so this is how I produce my 95% confidence interval. When we come back to school next week, we're going to look at what's the calculator doing, what's the formula for this interval, right? Build some understanding. But worst case, now we know how to use our graphing calculator, at least quickly get the interval. We're 95% confident that the true percent of all Midwest high school students who are hypertexters is somewhere between 18.6 and 21-ish% based on this sample. So that's the deal there. One more real quick. So back to our slides. Another context. So we've got the medical journal, The Lancet here, which I believe is from the United Kingdom or Britain. I don't know, like if it's one or the other specifically. But they have a medical study about the effectiveness of infliximab. There's an L missing there. but about the arthritis-fighting drug infliximab and how it treats Crohn's disease. So in the study, 335 of 573 patients who are suffering from Crohn's responded positively to injections of infliximab. We're not going to do this, so this question actually, right? Estimate the proportion of Crohn's patients similar to those in the study who will respond positively to infliximab. Again, right? That big idea we talked about today is anytime we want to estimate a parameter, the percent of all Crohn's patients who will respond positively, that means this would be a confidence interval, which would mean the full process, conditions, math, which is going to involve this calculator stuff we're looking at and some stuff we learned about a formula, and then interpret the interval, right? So just this question in this black box embeds all of this process. We'll save that for another day. For now, we just want to think about the information we're given. Think about this. We want X, N, P hat, no confidence level given. So first think to yourselves, 2 of these 3 green numbers are given. Which 2? And then how are we going to find the third one? Pause the video and try it out. And now that you've unpaused, hopefully you told me our total sample size right here is 573. Now this time we are given the number of successes, in this case, people who responded positively to infliximab. So in this example, we're given the X value, which is 335. P hat, right? So in this context, X represents the number of people in the sample who responded positively to injections. P hat represents the percent of people in the sample who respond positively. You don't need a formula for that. You know that. Well, 335 of the 573 people responded positively, and that gives us 0.585. So there's that. So that's how we can get X, N, and P hat from a context. The last thing I'll finish up with, I'll jump back to my calculator here just to show. So if we wanted to create the interval, I go stat tests. I go down to 1 proportion Z interval. We had 1 sample of Crohn's patients. We're talking about the percent who respond positively. That's why it's a 1 proportion situation. And it's an interval because we were trying to estimate a parameter. So I go to my 1 prop Z int. This time I know I already erased all, oh, they're right here in my calculator. X was 335, N was 573. We weren't given a confidence level, so when in doubt, we'll just use 95 as a general rule of thumb, and there we go. Now, one thing I always do, the reason I'm doing this in the calculator here is notice P hat's given, right? That should match, right, like what I had calculated. So we're 95% confident. True percent of Crohn's patients, similar to those in the study, we're going to respond positively to infliximab, somewhere between 54.4 and 62.5%. And so there's a quick look at how we can use our graphing calculator to produce the interval, but prior to that, how we can find the values of X, N, and P hat given a context. So use that stuff for like some of your take-home quiz or something.